Hello and welcome to TidyX episode 75. Wow, 75 episodes. TidyX is a screencast where we go through and explain how our code works. My name is Ellis Hughes, and you can find me on Twitter at Ellis_Hughes.
And my name's Patrick Ward. You can find me on Twitter at OSPPatrick. You can find the screencast on Twitter at tidy_explained, or drop us an email at tidy.explained@gmail.com, or open up an issue on the GitHub repo, or go to YouTube, hit the like, subscribe button, and make a comment, have a question, have a disagreement, whatever you'd like. Really, all totally fine.
It's all fair as long as we have a good conversation at the end of it, right?
That's exactly.
Really what matters. Yeah, definitely subscribe. We appreciate every subscription that we get. So episode 75, we're continuing our series on databases in SQL, and this time we're going to be continuing what we did last week, a little bit on joins, but now we're applying it to a Shiny app.
Yeah, the last 2 weeks, really. We've had 2 weeks ago was Shiny apps on the back end of SQL. Last week was joins on the back end of a SQL database.
Mm-hmm.
This week, we're meshing the two together, and we're adding a little bit of interactive piece for the user, right?
Exactly. So let's get into it. I will share my screen so Patrick knows what we're talking about here, and we will go away. Well, we won't go away. We're going to go here. There's that, so you can see us talking. But yes, TidyX episode 5, joins in the database using Shiny and user reactivity. So we'll just jump into it here. We've got our packages that we use, and it's pretty much the same packages we've used for the last several weeks here. Tidyverse for our data manipulation needs, rvest for reading stuff off the interwebs, Janitor for general helpful cleaning, RSQLite and DBI for connecting to databases and writing to them, and then Shiny widgets for our Shiny app, and then DT is also going to be part of our Shiny app, and DT is a great function or a great package that has some nice ways to share and view data tables.
Yeah, I feel like we've used it before. We must have used it before. We've done a number of table things, formattable and things like that. DT is probably in my day-to-day my preferred choice of data table packages because it's super easy to create them. The syntax is super logical, and you can make these like incredibly interactive for the user. Like we could set the show entries instead of defaulting to 10 to 100. All of the columns are sortable. We can put search bars over all of the columns aside from the kind of global search in the upper right. Like tons of options, conditional formatting, all kinds of stuff. This is probably my favorite table package to use, just in terms of ease of use for the person coding it and ease of use for the user, in interactivity for the user, rather. Yeah.
Exactly. So
I'm a fan. Yeah.
That's DT, everybody. All right, we're done. We don't
That's
need to
it.
do any more.
That's episode 74. Wait, you have episode 74 there.
Oh,
so
yes.
This is
this
is a
this is code. So we are more or less copying episode 74 for the data generation piece because it generated a bunch of play-by-play data that we wanted to be using for this data or for the Shiny app here. So the context for this. Actually, no. Let's not get into context. Let's just quickly run through this. So this is going to be pulling game play-by-play information. It takes a game ID, database connection, and then verbose, whether that's true or false. We'll print the game ID or not. That was for debugging. I think we touched on this a little bit, but this is just reaching out to ESPN's website, getting the play-by-play information and some game information, and storing that in a database for us. Bunch of really fun rvest type stuff. We've gone into that in detail in the past, so I'm not going to go through that. But really what matters is this piece here.
new piece.
Where it's going to be writing the game play-by-play information to a database. That's what we did last week. It's just now got a slightly different name where it's game_PBP_game ID. Yep. What's new, which is has this comment new here, is a data frame that I'm creating, and it's going to be empty. So it's not going to have any stuff in there. The way you do that is you call data.frame, the column name you want to be doing, and then you just call the class that you want to be using. So like numeric, so this column here is going to be play ID number. It's going to be an empty numeric column. Then the comments field is going to be an empty character, since the content would be a character. You could do an integer with an empty integer.
Do factors. You do.
Yeah, you can kind of build it up however you want, but we only wanted character, play ID, and comment, and that'll be our empty comments table, which we're then going to be writing into into the database, going game_comments_game ID. And then here it's just going to be adding in the generic game IDs table that is going to have all generic information about the game itself in there. And so this is more or less what we had last week. Let's run that. We're going to connect to the database. We've picked 4 games. These are the same 4 games as last week. So some of the Miami Heat and Milwaukee Bucks, and then a random Denver Nuggets and Portland Trail Blazers. Because why not?
Because Pacific Northwest.
PNW. Mm-hmm. So it's pulling all this information. It's reaching out to ESPN, a couple different websites or web pages on ESPN, pulling that down for us, organizing it, doing a bunch of really fun stuff. But it's done with all of that. And so now we've got this database. It's got all these tables here. So it's got these comments.
Yeah.
Tables here, and so they're labeled with game comments and then the ID. And by the way, I'm not saying that this is a good way to organize the data. I'm just saying this is how I did it to demo stuff.
and those game comments tables are all empty right now.
Yes, exactly.
There's nothing in them. Yep.
If I were to grab this one.
Yep. It should be just a totally empty
thingy. Yeah, empty table. Also probably not the best way to be creating these, but it's what I did.
Yeah. Mm-hmm.
Yeah, and so now we're going to disconnect, and I've been doing a lot of talking, so Patrick, do you maybe want to take us through this beginning piece of the Shiny app, like what it's for?
Yeah, so the kicker here is to use those comments tables to provide the coaches an opportunity to place comments on each of the plays, context as they're watching the play. Maybe they were like, hey, I hope everyone checks out this play, great pick and roll, blah, blah, blah. But not only comment on that and make it sort of like live on a piece of paper that they share around with their friends, but actually write it back to the database so that it can be stored. And maybe, if you're an analyst at this club, you can search all the times that coach so-and-so said, great play, perfect pick and roll. And you could pull those and you could, write out the play IDs to a video, and they could call the video from ESPN or something, and people could watch it and things like that. So here we are. We're going to connect to the database as we've done before, because we disconnected up above.
Mm-hmm.
And then we need a starting value for the UI. So the games available is going to go through that table using the table function. We call the database connection and the game IDs. And then we're pulling the game info. So remember that pull, that pull function from Tidyverse is basically saying, grab that column and just turn it into a single vector. So let's see where you're at there.
Yep. So sorry, I was just showing different ways to print it out.
Yeah.
Here's the different values that we have here. So these are the four games that we have. And these first 3 are the Milwaukee Bucks. And here, so you probably want to give it a better name, but
but you could see right up above that piece there, the games available, where you just called that. It turned the games available into a kind of a vector, a string of variables. And so we're going to use those here in the user interface in a second. We disconnect from the database. We're going to set up the user interface here. So obviously we'll give it a descriptive title, the 2021 playoffs. We're going to make this a sidebar panel because most of the Shiny apps that we build, we tend to put the user's interactive piece off to the side. So we're going to use the picker input from the Shiny Widgets package again. And so remember, this is that cool little drop down with the clicker that puts a little check mark next to it. And you input, the input ID is the game selection. So that's the actual ID of the data that we're going to be using then when we get to the server. The label is we're going to tell the user, hey, go ahead and select a game, colon. And the choices are going to come from the games available vector that we put right there. So that's where the information is going to come from, those choices, and they're going to be searched for once the user picks them in that input ID game selection, which we'll call in the server piece of the Shiny app. The main panel is where we allow the user to view the things, all the things, whatever those are, graphics or not. This time we're using a table. So we have DT. Remember, we're using a DT table. So we're going to use a DT output, which comes from the DT package. And then the UI output here is an output ID called commit button display. So the UI output here is a user interface output. It's going to be viewable in the main panel. It is not like a piece of data like the data table or like a figure, but it's actually a button. And the user is going to be able to click that button. And as the name suggests, that by clicking the button, it's going to commit the data back to the database for us and store it in that empty database that was created above. Mm-hmm. Empty data table.
Yes, exactly. So basically, this is UI UI in the Shiny app that can modify based on some other pieces, and so you actually want to put the code that describes the UI inside the server.
Yeah,
it's kind of like a weird situation because it's part of the UI, but we're defining it in the server, and this is what's allowing us to do that. But this isn't the point of this video here. It's just I thought it was nice to have.
Yep.
Alrighty. Now we're going to get into the server. Patrick, you want to continue?
The server, yeah, we can go on. So the server is going to have 3 inputs into the function: the input, the output, and the session. The session there is just to let us update things as we go, as the database interacts and learns new things. So we're going to create this empty reactive called reactive values, and it's called, we're going to assign that to displayed data. Right. So this is basically it's basically creating a section within the server where we can store the changes that people are making. So when Ellis goes in and types, great block on that dunk, it's there to store somewhere. Right.
Yeah.
Okay. So then moving on. So the observe event, we've got the input game selection, which the user is specifying. And then inside of here, we're going to do all of the kind of database stuff inside of the brackets there. So we connect to the database just as we've done before. We always, as good practice, set an on exit. Go ahead and disconnect because we don't want those database connections floating around there in our script. Okay. So then we have here, we're assigning the game ID value. We're going to connect to the database. We're going to filter by the game info and the input game selection. So this is going to be the user specified game selection information. And again, we're going to use that pull function to just pull the game ID. So basically we want just the number. And then from the comments data, we're doing doing a little paste 0, which is basically saying paste without any spaces or characters. We're going to paste game _ comments _ and then the game ID, right? So that's the table that we're going to write out to. Mm-hmm. Okay, so because that's why dbcon is there. So we're connecting to the database. We're going to write out to that table, and we're assigning that to comments. And then the play-by-play, we're again connecting to the database. We're saying paste 0, game PBP game ID. Because remember, right now, game ID that's just a numeric value that we allowed the user to select. So they're going to pull that game ID. We're going to say, hey, go into the database and grab the play-by-play data for the game ID that Ellis or whichever coach selected. And then we're going to left join. So we're going to do a little bit of a merger here. We're going to left join that up with the comments data. So we want the comments data would be lopped onto the end of that. Remember, we talked about, I think last week was the week where we went over joins a bit. And then we're going to arrange by play ID number, because we want this to be in the order of the game. So if they're like going through while they make comments, they can see the play-by-play data, they can watch on film, and then they can type their comments out in this section here.
Exactly.
And then finally, we're assigning some key things to the displayed data frame there. So the game ID, the comments, we're putting collect there. We talked a bit about collect last week, which basically turns the information from a lazy data frame into a real data frame. Then we're going to pop it on the end there. We've got the play-by-play data, and then we've got the comment commit up to date is true, which is basically when they commit this stuff, we want this to push up to the database, and then you'll see what happens to the button once they do that. And that just basically means that they made a change, they committed it to the database, and now the database says, yep, I got that change, and we're ready to move on.
Yep. It's all up to date. What I have is what's in the database is what you're seeing. So this is kind of just a flag that we use later on.
So now we're on to the data rendering. So this is the tricky part, where the table is basically taking the inputs from the user. I'm going to let Ellis explain. This is an incredibly, I've written several Shiny apps like this, and it's like a pain in the butt to figure out exactly what's going on or articulate it to anyone. But I'm like, just trust me, this works.
It's functional.
Yeah, you try and explain it.
All right, let's see if I can. All right, so now we have output to the PBP table, which is, remember, that DT output ID, right? We're going to be rendering a DT, so rendering the data table, and then this is the data that we're going to be rendering into a data table. And it's just the play-by-play information with the play information lopped on, or the comments merged into it. So it's play-by-play information with the coach's comments on it. But we have some options here on the data table. Like we said, it's incredibly flexible, and here is a way that it is flexible. So this first selection is none, means that by default none of the rows are selected in the data table, because occasionally when it pops up it'll automatically have like the first row selected, which is not what we want. We don't want it to be showing row names, so we set row names to be false, but we do want it to be editable, because the way that our UI is intended to work is the coach is going to be able to enter in the information right into the data DT table itself, so that it looks like it's right there with it. And so this is editable equals true. So we set it up to be editable, but now we need a way in order to capture that information and store it and actually make it real. And so it follows this process here, and I can't fully explain what's going on here. I will do my best in the sense that I don't necessarily know what's going on under the hood, like why we have to do this, but we have to set up a data table proxy. Apparently we need that that identifies some sort of information to another function that it can't get on its own. So we need to set up this proxy. And so I think this is the ID of the output DT, say that 10 times fast, and saying, okay, this is now the proxy. And so now we have that all identified. Now we're going to have some sort of observe event. And so if you look here, and this is kind of unique because it's actually created a new input. So the PBP table normally is an output, but now we're actually looking at cell edits. And so this is now an input into our Shiny app. So see that it's kind of flipping back and forth. And anytime this value updates, so anytime somebody's now edited a cell, it's going to kick off this next set of code. It's going to be reactive. First, this is going to pull in all the information. So which cell did we edit and what did we edit it to? And so it's going to pull the row, it's going to pull the column, and apparently it's 0 offset. Normally, like when we're doing stuff in R, we're usually 1 offset, which means the first entry in a vector or first column in a data frame is, we call it 1. Well, in other languages, it's 0. So, and for some reason, the information that they store in this uses 0 base as well. So we need to add 1 so that it's 1 based for us. And then we're going to pull the value here. But unfortunately, in data table, you can't make only a single column editable. It is the entire darn thing. And so what we want to do is we want to limit the edits that a coach could make to the table itself. And so we're going to have this if statement here. So we're going to check to see whether the column that they make an edit in is actually the comments column. If it does, it's going to start doing some code. If it doesn't, it goes, nope, you didn't make a change. And actually, we'll skip forward to replace to this function here, which is what puts in the new quote new data that we just generated. But really what it's going to do is going to repopulate it with the original data. So the changes of the coach or whoever, I guess the user of the Shiny app, it's not going to look like they made any changes because we don't want them to make any other changes other than the comments column. Now here, it's going to go through some logic. First identifying which play are they referencing. And so it's going to pull out the play ID number based on the row number that they're using. Then we're going to go through and pull the comments that we have here, and we're going to make sure, because it's possible that they update the same comment. They could enter it multiple times or make edits on the same comment, and so we wanted the ability to update those. And so this is what this piece is doing. It's binding rows, so it's going to be removing any cases where it's only going to be keeping the cases where the play number is not the play that they are editing, and then it's going to bind it into another data frame that has the play number and that new comment that they're making, and update the displayed data comments entry. And then here it's going to be updating the display data P by PBP data frame, which is the play-by-play data frame, if you remember, with the comments joined onto it. We're going to remove the comments that were already there because we're adding new ones on. We're going to be left joining with the comments that we wrote. And remember, this left join allows us to keep all the play-by-play information and only add on the comments that we made. So there's probably going to be, most plays are not going to have comments, at the very least in the very beginning. Eventually there might. All of them might have comments eventually, but initially there are none. But we want to keep still all the play information. That's why you do a left join. And then we're going to arrange by play ID number just to make sure that it's in the order in the game, the way that it was done in the game. But now that they've made this comment here, we want to set up the flag that we have telling, like, hey, all the comments you've had are up to date, they're in a database. That's not false because they've made comments and they haven't committed them yet. And so this now will flip to false, and that's going to trigger a change in the UI, which we'll get to in a second. So now it's updated this PBP data frame in display data, and now it's going to update the DT output to this new data frame that has these new comments in it, and go, hey, here's these new comments. And it's really not going to look like, this is a lot of code. It's not going to look super impressive, unfortunately, in the actual Shiny app, but this was a lot of logic to try to like sort out to make it so you could do this specifically so that we could do this other piece as well, which is saving the data, which we'll get into. So now we're going to have this output commit button display. So the button displays that the UI output, so it can change. It's like basically an empty div, so an empty entry in the Shiny app that can change the contents there. And so we're going to put this inside of a render UI. So this is kind of similar to like any of the other render functions. So this is like, we're going to be pushing this output to the UI, and here we're saying if this statement is false, so if the comment commit is up to date, if that's false, then show this button saying, hey, click me to commit your comments. Because right now, so when you first open it up, it's not going to show up because there's no comments to commit. As soon as you make a comment, it'll then pop up because it's reactive and go, hey, you've made comments, but you haven't shared them to the database. Click on me to do that. But as soon as they click on it, then it's up to date, and we'll get into that code in a second. And then it'll go away because they've already committed it. There's no reason to have that button there still because it's up to date.
It's there, yeah.
And then here is a very simple, I don't want to call it simple, that negates the complexity of it, and if it's not straightforward, we're not explaining it. But we're doing another observe event. So basically, this entire Shiny app is a bunch of observe events. It's looking for a bunch of like, well, hey, when a change happens, do a thing. And that's kind of what reactives are doing, but a little bit more complicated. Here, we are specifying when it sees an update, do a thing. So when it's seeing a change to the commit button, which is when they click on that button, it's going to change that value. Connect to the database. Set it up so when this execution ends, it's going to disconnect from the database so we don't have connections floating around. It's going to write to the database for us using our database connection. It's going to put in to that what was an empty table of game underscore comments underscore game ID number, or update them if there are already comments in there with the data frame of comments that we have. And it'll overwrite them so that way, because we just want to push the updates. We don't want it to stop. And then it'll change this flag to be true, because now all our comments and updates are true and correct. They are in the database, so that's now true. So that was a lot of explanation for
well,
this.
Let's run it. Let's run it and see what it looks like.
Yes. Let me make sure I ran the UI.
Yeah, I don't know if you ran the UI. Yeah.
And our Shiny app here. Let me zoom out a bit so that it looks, and I can move this over here. So this is our Shiny app. This is how they select a game. So in the future, we might set it up so it'll show them which teams it is. However, they should know, like if they're coaches, they probably know which team was in the East first round. Mm-hmm. So how we have, game 2, and say they were watching this on film, and they're like, oh, that was good. They can double click on this and go, whoa, Nelly, or who is this? We need to guard him. I don't know, but now they've clicked it. It's in this DT or this data table here, but it's not in the database. It doesn't exist. So like if they go to look at another game and then go, oh wait, did I commit that? No, it's gone because they didn't save it. They didn't commit it. And that could be seen as both a feature and a bug, depending on your feels.
Notice before you type in this that the button is not there.
Yes.
This is purely observable. Once you type something, right, then hit enter or move out of the cell that you're typing in. Now it says click save, and now it's prepared to save. So now that you've clicked it, now it's good. So now move away and go to game 1, and then go back to game 2. And because it's in that database, when the server calls that data frame out of that database, it says like, hey, someone saved this comment. And you could, so if you go back to that comment, you could say, oh, I actually meant to say bad pass or something, right? And then you can change it, or actually, nah. stuff.
Yeah, but now, the update still won't be pushed to the database until you
commit it. Yeah.
Click to save comments.
And now it's there.
Now it's there. So now we go to another game, come back, still there. And so you can do this to any one of these, blah, 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 blah. Unfortunately, it does reset you to the first page of the data table.
Yeah. So you could set the data table to default to 100 entries or something like that if you want.
Yeah, if you really wanted to make it
many
so
more.
That
yeah.
Well, that's how you could do it. That's how you can use databases with your Shiny app to make it so that your coaches, or I guess whoever, it doesn't always have to be a coaching situation, but they can make comments there and then save them to your database for future reference. Because this could also be useful for, I don't know, if you have some data and you want to farm it out to a bunch of assistants or something just to get like their thoughts on something so that you can do a data analysis project later. Mm-hmm. They just go through, enter in their stuff, blah, 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 blah.
Or
save it.
This would be great for if you think back to our PitchFX predictive modeling. There was like 700 some pitches or 500 some pitches that were not classified by the PitchFX system. So this same thing, you could, ship this off to an intern and say, hey, quickly go through these 700 pitches and write down whether it was a fastball, a changeup, a cutter, whatever. And now you have those manually coded for you, which, something like this, and then they save it back to the database, and now it's there, and you can keep running your model or, doing whatever. If your model's in production, it just picks up the new changes in the database and goes.
Yeah, exactly. And there you go. That's how you can connect your database to a Shiny app, make some updates on the fly in your Shiny app, and make it actually persist. Because I guess what we didn't show is you can stop that, restart it, and these comments are going to persist. They're still there. They don't go away.
Yep, they're part of the database.
It's part of the database now, and that's how you can get persistence across your Shiny apps. There we go. Cool. Let's call it here, though. We're 30 minutes in. So thank you all for joining us so much. Please subscribe. My name is Ellis Hughes, and you can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward. You can find me on Twitter at OSPPatrick, or you can find the screencast on Twitter at Tidy_Explained. The subscribe he's talking about is on YouTube, on the YouTube channel. Go ahead and subscribe, drop some comments. Drop us an email if you'd like, tidy.explain@gmail.com, or open up a issue in the GitHub repo. Either way, let us know maybe what you'd like to see next from a series, or maybe you want us to keep working on databases. We don't know unless you tell us. We don't know. So feel free to tell us.
Exactly. But thank you all so much for joining us for 75 episodes. Keep on exploring your world.